Hello, it is I, your internet friend, Robert Kadarian. Today, we are going to talk about Python for people who have programmed before. And that's really what this whole primer thing is that you are a programmer. You've gone through some degree of programming courses, probably first year, maybe even second year of computer science. And now we're going to get really stuck into it because you've got to use Python for an assignment or something. So, I think we have to stop with Hello World. Start. Let's start with Hello World. And it's really easy. It's stunningly easy, actually. Do I actually have one here? I might not. I don't think I do. Let's do this. No, I do. This is the fanciest version. Print Hello World. But I also have this thing going on up here, and Python 3, which will find Python 3 on my computer and run it from somewhere. It'll find it on the path generally. So it should find in my computer opt homebrew bin Python 3. It's kind of gross. Usually it's under user bin or it's symlink there or something. And then you can just grab it out of there. But that's actually a really important line because Python is interpreted. And we use the hashbang to determine which program is going to interpret this file. You'll often see hashbang user bin Python. That is a very normal place for Python to be. And if I saw this on an assignment, I wouldn't bat an eye. And I don't. But if you're using something that's a little bit more, or if you're writing something that needs to be a little more portable for anyone else's computers, you might use the env thing that I used in that example. But both are fine. And because of that, I can do two different things with this file. I can say Python 3, calling it by name. So I'm invoking the Python executable, which is going to interpret hello.py, and it's going to, guess what? Print out hello world. Bet you're shocked. I can also see if this file is executable, and it is not. So I can say chmod, change mode, plus X. I'm going to say 8. Yeah. Okay, I think I just do plus X. Let's find out. Hello.py. And now, let's see if it's executable. Oh, shock, it is. So I can say hello.py. It's going to find Python somewhere on my computer and probably on the path. I'm not actually certain how env works. And we'll execute Python, interpret the file that is passed, and boom, hello world. That sounds really complicated, but it's not. And you usually don't come across it very often. But just knowing you can make something executable and choose the interpreter is really what we want. Interesting things about Python. You don't need brackets for your if statements. That's nice. You can just say if a thing, if not a thing and greater than whatever. This is a stupid if statement. Then you can run your if statement. If you can use brackets, brackets will give us flexible white space. So if I wanted to put this on multiple lines, I'd need to put smooth braces around it. And then I'd still have to end it in the colon and then still need the indent. Generally, the indents are for spaces. Some people use tabs. I don't care. Don't mix them. That's it. And then once you dedent, you can see the bottom line of code here is print done the if. That is going to run after this if statement. So if this if statement did not trigger, it's going to go straight to the end of the code block and run the print done the if statement. Shocking. What if we need else if? This is one of the things I hate about Python. Elif. Why? Fine, I can live. So if, elif, else. You can see that I use braces in this one. Doesn't matter. If you like the way that feels, you do you. But some people like having bare comparisons. I don't care. I want it to work. And that's probably your opinion too. There's data structures built in. So these are not something you need to include. They are just available for you immediately. One of them is a list. That's square brackets. This is not an array. Arrays are fixed size and one single data type. These lists are any data type, and it is flexible size. So that means that we can append data in, and it'll happily append that data to our list and have mixed types and do whatever. There is a lot of really bad things you can do with this. Don't mix types in a list. That's a bad idea. Look up the tuple data type if you need to have a row, like where it's like a record where it's like names and then an age and then a date. You look up tuple. It's really important. It's immutable. Very neat. But that is also just built into Python. Lists are supposed to be like arrays in the fact that they should be one data type and hold data in an ordered fashion. That's it. Now it's just flexible. You can append and do nice things. So it's basically what you want an array to be, and it will just work for you. We get tables for free. This is your dictionary data type or a table data type, whatever you want to call it. It's a key value store. You can add keys and then get the values and then modify the values. It's basically a really super duper lightweight object. You don't have functions, so it's maybe a little bit more struct-like, and it's free. You just get it. You can declare an empty one using these curly braces, or you can, and then you can add a key by just saying key, or you can actually load up a dictionary and have a loaded dictionary from moment one. I actually really like that, especially if you have default values and you always want to have these keys and you want these default values to be assigned to these keys. Boom, you got it. It's there. You're running. And I use that pattern a lot. I think it's very useful and it's kind of pretty. And having mixed data here is not an anti-pattern because they're key value pairs. So if you had a user object, and it's not an object, it's user struct. So you would have a name key, and that would probably be a string for the value. And you have an age key, and then you'd probably have a float or maybe an int, something useful like that. Then a birthday key that might have a date. And mixing those makes sense. You probably want an object at some point, but that's not what we're talking about right now. Loops, very important things to be able to do. While loop is exactly what you'd expect. Not a lot of conversation to be had here. Interesting thing, Python doesn't have plus plus, so you have to plus equals 1 if you want to have that increment thing go on. Why doesn't it have plus plus? I don't know. I just don't even know. And it'll run while something's true. It runs the code block. Once the code block dedents, your loop is over. You get really used to having good white space in Python. The for operator is a bit of a mess, in my opinion. There is no C-style for where you have your initialization, continuation, increment. And if you don't know what I mean by that, I'm sorry. And that means that this is more of an iterator. Give it an iterable, and it'll iterate over everything in that iterable. That sounds fancy. It's not. This is a list is iterable. A string is iterable. A set is iterable. It means that you can iterate over every item in some kind of set. Good. But the problem is that it always wants to iterate over every item in a set. You can't have a exit condition. You have to use a break. So you end up using break in Python, and that will make some people who teach classes very angry. But that's just the way that Python works here. You might want to use a while loop if you need to exit early. For loops should be reserved for when you want to iterate over the entire set and have that work like that. Otherwise, you're doing a bit of an anti-pattern if you use breaks. I'm sorry. Especially if your for loop is like 16 lines of code and you have 5 breaks. Don't do that. If you want to have a for like loop and there is still no early way to exit other than break, you can use the range built-in function. And check out the page on built-in functions on Python's website. There's a whole bunch of them. Range is one of them. It'll give you a range from 0 and up to not including the value pass. There's actually a few optional arguments, so you can have a start point and end point, and it goes up to not including that endpoint, which is exactly what you want because you have done programming. So you go from 0 up to not including a number. You're not surprised by that, right? File-like objects. This is actually, it sounds really fancy and sounds also at the same time kind of hands off. It's like, oh, what's a file like objects? Is it a file? It is not a file? I don't know. You get used to it. Is the best thing that you can possibly say. This is a hyperlink. You should have a PDF available. And the funny thing is that file objects are more flexible than you'd expect. You could have a file that is static and text and has a start point and end point and doesn't change. But standard in is a file-like object. Sockets are a file-like objects where there's text coming in, but there's no definite end. You can keep on reading, and if you can read, then you can read it like a file, and then makes your life easier to say this is a file, not a stream or a socket or a there's some built-in operating system thing I'm forgetting right now. That's okay. But you get 3 functions: read, write, and seek. That's it. So you can read from this file or stream or whatever it is. It's a file-like object. You can write to it. Some of them are write only. And you can seek, which means you can move around. And again, if it's not permitted, it'll just throw an exception and say, don't do that. And that's fine. Opening files is terribly easy. Think about doing this in Java. Java takes 2 lines of code and there's about 35 characters per line of code. We just use open. That's pretty good. And this will, guess what? Open the file. You can pass a mode here. Read, write, execute, append. Not execute. Read, write, append. And you can even truncate, or you can... There's a bunch of different ways you can write to a file. Look into what you want. Generally, you want to overwrite, but you can also append if you wanted to. That's cool. You might want to be in read write. It gets a little funny, but sure, why not? And then you can read the whole file by just saying read. There's also read lines, or we can use a for loop to iterate over it, because why not? For will auto-magically iterate over lines in a file, because that's generally what you want. So that's what it did for you. If you want to do something different, you could arrange that above your for loop and then iterate through the whatever you want to iterate through. Words, letters, some other thing. That's fine. But for free, you could actually even be cool and say, move this open line to here for line in open file blah, and it'll just iterate over that whole file. It's quite a beautiful thing. Standard in is a file-like object. So import sys, that's how we import things. There's a whole bunch of things that you can import. That's actually one of the great things about Python. There is a vast variety of libraries that we can just use. And then we can say with standard in, I'm going to call it instream. I stole this from somewhere because that's not what I would usually name it. And then I can read line by line the standard in. And that's when somebody's typing on a keyboard, that's standard in. Or if you're piping data into this program, that is also standard in. So this will read that standard in. In this case, it'll just print the last line. Sure, well, let's do that. And if we use the with statement, it'll automatically close that stream at the end, so we won't have a hanging resource. Very nice. Super expressive. Like, it's an incredible language. Functions, guess what? Code blocks. We use the def keyword, very important. And we could give the parameters names, types. That is pretty much the last slide in here. And we could also set default values. So I could say parameters equals null, none. Null is not a thing in Python, it's none. And go here is equal to 2 if it's an integer type. So that's pretty handy. Actually, I guess these are both strings, so maybe I want to set them to empty strings. And that would be parameters equals empty string, go here equals empty string. And that would be your default values, and then you could just call a function name with no arguments. Your default values will go, and you're done. Super nice. These are scoped to within this function, which is important. And it can actually read anything from the scope above it. That's one of the dangerous things about Python because it lets you do that for basically free. So anything that is on the kind of the main scope, you can read within a function. But if you try to write to it, then it's going to give you a new variable with that same name. That's not pretty. So you can look into the global keyword if you actually want to use a global variable. Again, anti-pattern, don't do it. but you can. But I'm going to make you do the research yourself. And I feel like that's completely fair. Objects. Here's another thing I hate about Python. Here we go. These are called dunder methods. There is a few of them. 3 of them I know by heart. Init is your constructor. Underscore underscore str underscore underscore is your toString function. Underscore underscore repr representation. Underscore underscore is your how it'll print out in the command line. So that's like the representation of the object versus what you want to pretty print it to. And there's 2 ways you can print an object. Look it up. All of them you have to pass self to, which is the scope of your instantiated object. I really don't like that. It gets messy and verbose and icky. And then if you want to use your instance variables, you have to prefix it with self dot whatever your attribute is. If you want to call one of your own instance methods, you have to say instance method self dot whatever your instance method is. So self dot add age. Again, not a huge fan of it, but at the same time, we get objects. We can use Python as an object-oriented language, or we can just use it as a scripting language. Hey, that's pretty cool. So don't write off how handy that can be. And you can set variables that are like class variables or like your other ways to set your how you want to initialize. I really like initializing inside of init, but you can look into how class variables and stuff, if you have things outside of a method get interpreted. I find it gets messy and confusing, so I don't do it. I like readable code. Okay, Python is untyped language, or loosely typed, whatever you want to call it. We can actually type it. And this is kind of handy. So def function, we can say colon, this is an integer, colon, this is a string, and I return a string. Now, why would I want to do that? Well, it's not enforced. This is just for hints inside of your IDE. So if you're using something like Visual Studio Code, which I actually do, it'll be able to tell you, it'll know what objects are returned from a function, and then it'll give you, look up that object and then give you whatever attributes or functions you can run when you say my object dot. And it's like, oh, I can say dot add age and dot whatever. And oh, here's the set of parameters it takes, and here's the types. And it'll give you all the help string and stuff. So I've started doing this. You'll see that a bunch of examples I have inside of the code base examples are typed. I'm trying it out. I still haven't fully formed an opinion. I think I like it for bigger programs, and I think I wouldn't do it for like short 10-liner programs. But I'm not certain. We'll see. Ask me again next year. Debugging. This is really better set by an example, and I believe there is a debugging example in Python available. My favorite way of doing this, and I'll do it in the factorial, no, I'll do it in FizzBuzz, is to go in, and I'm going to say here, 1, 2, 3, 4, import pdb.set trace. And I'll always write it on the same line because I can actually just clean it up afterwards, and that's kind of nice. Right quit. And then when I run this, I'm going to say Python 3. I have a whole bunch of Pythons on my computer, so I have to do that. It'll stop my execution. I can use L to list out my code, and I can inspect my variables now. So I can print, I can type it all the way out. What is my index? Yeah. P index, fine. It'll print it out. Apparently you have to do it that way. I could just type index, which gets dangerous if you have a variable named like C, because C is continue, and then your programming will continue. Don't have 1-letter variables, but don't ask me how I know that either. I can also press N to step to the next line of code, and then I can just hit enter to repeat, and you can see that what it's returning and doing all this nice stuff. So you can see that it's returning a 2 right now, and I can keep on going next. And now I'm in my for loop, and it'll just keep on going, and I can press C to continue, and then I'm going to press Q to quit because I'm done with that example. But yeah, the idea of just easily having this line of code available, and then you can just delete when you're done, I think is pretty nice. There is a way to just say have a PDB shell. I forget how to do it because I've done it once in my life. And then you can load up your file that you want to debug, and then you'll be able to mess around with your file from the beginning line of code and set breakpoints. I find that's a lot of work, and I debug small. I don't debug big, so I find the just dropping that line of code in there is adequate for my uses. But find your own flavor. Figure out how you want to do it on your own. And guess what? No semicolons. So all that to say, Python's great. You'll find that you'll love it. You'll find that you hate it. It's a programming language. It's a tool, and I find it pretty useful. So I hope you're having a nice day, and I'll talk to you next time.